So, welcome to Single Cycle episode number 1 about processors and CPUs, and because we don't have a lot of time, let's get right to it. Let's start with the outside. The left is the outside of the processor with the integrated heat spreader, and on the right you can see the bottom side of the CPU with the pads which connect to a socket as well as some filter capacitors for power delivery. This is the socket. In this case the pins are on the socket because the pads are on the CPU, and it can be the other way around because some designs tend to use this one, so the pins are on the processor and there are holes where the pins go on the socket, as you can see right here. The next thing is this is the land map which shows all the connections on the CPU, so let's get right how the CPU processes stuff. First thing, we load the data in and increment the program counter. After loading the data in and getting it into the register, we then decode the instructions and process the instructions in the ALU and in the processor. We write back this result in the registers and update the status register. Then we can write data back into the RAM if we want to. This cycle repeats endlessly. This is the CPU die. These are the CPU cores. These are the L2 cages here, which are directly connected to the cores. This is the shared cage, which is connected equally to all the cores. Then the memory control unit, and the thing in the middle is the thing that handles the Q and the I/O. And the next thing, which is very important, is to remember that the CPU does not equal microcontrollers. There's a big difference here. And it also does not equal the FPGA, even though the FPGA can be programmed to be one. So I hope you enjoyed this short explanation, and a longer explanation with more detail is available on the channel as well, so feel free to check it out.